Hi everyone, welcome back to the course on Introduction to Material Science and Engineering offered by EdupediaWorld. Previous lectures, I introduced you to the concept of crystalline materials and amorphous materials and how there is a long-range ordering in crystalline materials. Now, with this idea, you might think that should a crystalline material have order throughout the material, or in a part of the material, a part of the specimen? So this is the exact question which I addressed in the previous lecture, in which I showed you the difference between single crystal and polycrystal. A single crystal is one where there is the complete specimen has order throughout the specimen, whereas polycrystal has different crystals throughout the specimen. But now imagine you have, even if you have a single crystal or if you have a polycrystal, then is it possible that there is a ununiformity within the material? Or is it that even for a single crystal or for a polycrystal, there has to be exact ordering throughout the material? What I mean is that all the atoms should be at exact position. No atom should be missing from anywhere. No additional atom should be anywhere. Is that the case? As we'll see in today's lecture, that is not the case. So our discussion will be on imperfections in solid. The case we have studied till now are perfect solids. Are crystalline materials perfectly ordered? That is the question. And as I said, no. So if the crystalline material is not perfectly ordered, then what is the exact scenario? What is the practical scenario? There are actually a large number of imperfections present in any crystalline material, be it single crystal, be it polycrystals. The type of imperfection present may be different in single crystal and polycrystalline material, as we'll see. And also within the polycrystalline material, there may be different kind of imperfections present. So this particular kind of imperfections which are present in a crystalline material are known as defects. So as the term suggests, defect is kind of a deviation from perfection. That's why defects. And these defects, you might think that the defects which are there hamper the properties. But as a matter of fact, the defects are sometimes very important for property enhancement too, because all the applications have different requirements, and different applications requirements can be met by tailoring the amount of defect and the types of defect we have in the material. So the properties are profoundly affected by the defects that are present in the material. And defects in crystalline material or crystalline lattice is irregularity in one or more dimension. So what this means is that defects can be rather not just one or more dimension, it can even be in 0 dimension, as we'll see. It can even be 0 dimension. So crystalline or lattice irregularity, which is known as imperfections or defects, can be in 0 dimension or point defect, 1 dimension or line defect, 2 dimension or surface defect, and 3 dimensional or what is known as volume defect. So to begin with our study, let us see what are the point defects that are present in a solid, or the 0 dimensional defects. In metals, we can have either vacancy or self-interstitials. We'll see in details about each of the individual type of defect in the coming lectures, but just to give you a brief glimpse, vacancy means an atom is absent where there should be an atom, whereas self-interstitial means an extra atom is present in the void between atoms. So this is effectively less atom than there should be. This is effectively more atom than there should be. Then point defects in the case of ceramics can be Frenkel defect and Sochotky defect. Frenkel defect is basically an atom missing from its location and is located at a different location. Sochotky defect is basically two atoms missing. We'll see in details later. Then we have impurities that can be both in metal case and ceramic case. Now what do I mean by impurities? See, the idea is that for a particular metal or for a particular ceramic, the composition is defined. Let's say, for example, iron. Iron has Fe atoms present at its lattice sites, right? But suppose that we add something to iron. Let's say we add carbon that makes steel. So in addition to the iron that was initially there, we now have additional element which was not supposed to be there, that is carbon. So these thing which is externally added or which is externally present, which should not be there, are known as impurities, right? Now the impurities can be present both in the metal case as well as the ceramic case. And what are the type of defects that can be under the categorization of impurities? The type of defect will be substitutional or interstitial. As the name suggests, substitutional impurities will be impurities which will substitute a metal or ceramic atom from its initial position. So the impurity atom will displace a original atom and take its position. That is substitutional. Interstitial is the impurity atom will go and sit at an interstitial site. It will not displace any atom. So these all are, broadly speaking, the point defects that can be present in a solid. Now that we have an idea about the point defects, we'll see all of them in details and their importance, their significance, how they affect the properties of solid in coming lectures. Next, let us see line defect. Line defect, as the name suggests, line is a one dimension. So line defect are basically one-dimensional defects. So instead of atoms missing, there will be line of atom missing or line of additional atoms present where there should not be, right? So the line defect is basically known as dislocation. Dislocation can be of two categories. It can either be a edge dislocation or it can be a screw dislocation. A third category is basically a combination of edge and screw dislocation, which is known as mixed dislocation. I'm not going into the details about these things. This is a brief introduction. We'll go into the details in coming lectures. So now we know what is line defect. Next, let us see what are the surface defects possible. Surface defect, as the name suggests, any surface is a two-dimensional thing, right? So a surface defect is a two-dimensional defect or two-dimensional imperfection in a solid. So what are the possible surface defects? Some of the possible surface defects are the external surface, right? External surface is actually a discontinuity. So ideally there should not be any external surface. The atoms should keep on arranging till infinity for the perfect crystalline material to exist. But obviously that is not a practical scenario. The specimen need to end somewhere because it is a finite specimen. So it will obviously have an external surface. And that is a discontinuity, thereby that is a imperfection. Then secondly, we have what is known as grain boundaries. This grain boundaries comes into picture in the case of polycrystalline materials. As I have discussed in the previous lecture, polycrystalline materials are materials which have different regions of crystallinity, and each crystal region, or what is known as each grain, has a orientation mismatch with its surrounding grain. Thereby these grains are separated by a discontinuity which is known as the grain boundary, and this grain boundary, being a boundary, is a two-dimensional defect. Then we'll see something which is known as twin boundary. So these three are examples of surface defects. There are other surface defects too, but our point of concern will be mainly discussing these three surface defect. Finally, now we have done 0D, 1D, 2D. Let's see the three-dimensional defects. So imperfections in solid can be in 3 dimension too. What are the possible examples? Some of the possible examples can be that it can be a pore, right? There can be porosity within the material. A material is completely absent from a region, so that region is a 3-dimensional region, right? So pore is a 3-dimensional defect. Then there can be cracks. There can be foreign inclusions. There can be inclusion particles or impurity particles present rather than atoms. So those things will cover 3-dimensional region. Thereby it will be a volume defect. Also there can be different phase, completely other phase present which is not supposed to be there. So this kind of makes the 3-dimensional defect. Today's lecture was a basic introduction to the imperfections in a solid present. We saw the different kinds of 0-dimensional or point defects, 1-dimensional or line defect, 2D or surface defect, and 3-dimensional defects or volume defects. Next lecture we'll discuss in details the idea behind point defects, what is the utility and the result of point defects, what are the different kind of point defects. These things we'll see in details. So hope you'll be here to understand more about the point defect concept. Till the next class, have a great day. Goodbye.